surface area of pyramids and cones. When we're finding the surface area of any 3D shape, there's the lateral area. Lateral area is, if it's standing straight up, the area of the shape around the figure. Here, if I were to lay out the lateral area of a pyramid, I would have 4 congruent triangles. My lateral area here is 1/2 times P, which is the perimeter, times A, which is the slant height. We use the perimeter because each one of these triangles are congruent. To find the area of a triangle, we take the base times the height. My height of each triangle is my A, that's the slant height. And instead of finding the area of 4 separate triangles, we're using the perimeter of each so that we can take care of it all in one step. To find the surface area of the pyramid, S is equal to L plus B. L is the lateral area, and B is the area of the base. Make sure to write down this information. If I'm looking for the surface area of a regular square pyramid with base edge length 5 and slant height 9, my surface area is equal to L plus B, which is also equal to 1/2 times the perimeter times my slant height plus the area of the base. So my lateral area would be 1/2. To find the perimeter of the base would be 5 times 4, since we have a square, which would be 20, and my slant height is 9. To find the area of the base, it'd be 5 squared. So 1/2 times 20 times 9 would give me 90. 5 squared is 25, which is equal to 115 inches squared. Surface area is always squared units because we are talking about area. Area always has square units. We want to find the lateral area and the surface area of a regular triangular pyramid with base edge 6 feet and slant height 10 feet. First, it's asking for my lateral area, which is 1/2 times the perimeter times my slant height. So my lateral area will be equal to 1/2. If it's a regular triangle, we would do 6 times 3, which is 18, and my slant height, which is 10. So my lateral area will be equal to 90. Now, if I draw a picture of just the base of this pyramid, and if this is a regular triangular pyramid, that means the base is an equilateral triangle. So this whole side length here is equal to 6. Now, if I draw the height of this triangle, I know that this length is also equal to 6. Once I draw the height, just this length here will be half that, which would be 3. So if I'm looking for the height of this triangle, because I had to find the area of the base, I'm going to have a squared plus b squared is equal to c squared. C is always going to be across from a 90-degree angle. It's always the hypotenuse. So if I'm looking for b, I take 3 squared, which is 9, and 6 squared, which is 36, and I subtract 9 from both sides. B squared will be equal to the square root of 27, which is roughly about 5.2. If I'm looking for the area of the base triangle now, the area of the base will be equal to my base, which is 6, times my height, which is 5.20, divided by 2. That's the area of a triangle, which is roughly about 15.6. So to find the total area, surface area of my equilateral triangle, I do 90 plus 15.6 to get 105.6 feet squared. Units is always squared for area. Now when I'm talking about the surface area of a cone, this also has its lateral area. If I were to flatten out my cone into a net, this is what it would look like. The lateral area of a cone is pi times the radius times A. A is equal to your slant height. This will give me the area of this shaded region. The surface area of the cone is L plus B. L being your lateral area, and B being the area of the base, which is radius squared times pi. Make sure to write down this information. A right cone with radius 2 meters and slant height 3. So I have R is equal to 2 and A is equal to 3. So if I first find my lateral area is equal to pi times RA. So my lateral area for this cone would be 2 times 3 times pi, which is equal to 6 pi. And if I want to find the area of my base, it's radius squared times pi, which is equal to 4 pi. Now I have to add these two together, and since they both have pi as units, I can add them both, which would give me 10 pi. Now you can either have the answer 10 pi meters squared, or if you just were to solve this out, it would be 31.4 meters squared. Now if I'm given a cone like this, I do not have the slant height of this cone. So I have to find the slant height. Here, I am given the height of the cone, and it creates a right triangle. So if I label this side A, B, and C, I can use the Pythagorean theorem. 12 squared plus 5 squared will equals C squared. So 144 plus 25 will equal C squared, which is the same thing as 169 equals C squared, and take the square root of both sides. 13 is equal to C. So now I have my radius is equal to 5, my slant height is equal to 13. So first I have to find my lateral area, which is 5 times 13 times pi, and add that to my base area, which my radius is 5, so it would be 5 squared times pi. 5 times 13, 65 pi, plus 25 pi is equal to 90 pi, and my units are feet squared. If you were to multiply that out, that would be 282.6 feet squared. So I'm looking for a regular square pyramid with base edge length 14 centimeters and slant height 25 centimeters. I first take 1/2 times my perimeter, which would be 14 times 4, which is 56, times my slant height. I also have to take the area of the base. If one side length is 14, it would be 14 squared is the area of the base. So it would have 700 plus 196, which is equal to 896 centimeters squared. Here we have a compound figure. So I have to find the area of the cylinder and the area of the cone. Now when I'm finding the area of the cylinder, first I'm going to find the area of this lateral area right here, which would be the circumference of the circle, which is 2 times the radius times pi, times the height, which is 45. That will give me the area, the lateral area of the cylinder. If I'm looking, I have to add that to the area of the base of the cylinder. There's only one base since the cone is sitting on top. So that'd be the radius squared times pi. Then I also have to add the lateral area of the cone, which would be 28. This right here is 70. Please fill that in. 70 centimeters. 28 times 25 pi. Did I do that? So if I add these all up, I would get 4,004 pi centimeters squared, or 12,572.56 centimeters squared. Homework is on page 693, 3 through 11, 13 through 21, 50 through 52.